All right, we have our final example of this relative max-min first derivative test set of notes. Another AP question with 2 follow-ups. So we have a graph of f prime again. My face is going to be in the way. It'll move me. Given to us in the figure. I've moved it down to the bottom. And we are being asked to find all coordinates with which f has a relative maximum. Now again, don't get distracted by the fact that our graph looks like it has a maximum somewhere. That doesn't matter because this is a graph of f prime and we want to know about f. So we know if we want to relate these two, f has a relative maximum when f prime has made the switch from positive to negative, right? Because that means I went from increasing to decreasing. So we can make our table if we want. In fact, I'm just going to make the table on the graph this time. Okay, so if we had a plus minus table here, we would have a plus in this section, and then we'd have a big fat section of minus, right? We could go ahead and bring all of our zeros down here. 0, 0, endpoint. All right, so if the only place we went from positive to negative, which is what we were looking for here, is at -2. So at x is -2. X is equal to -2. That's going to be our relative maximum. F of x has a relative maximum because, and here's the nice thing about writing down what I wrote down, I can just put an arrow to it. There you go. We changed signs from positive to negative. All right, let's keep going. What are the critical values of f? So we've been playing around with our critical values a bunch on that open interval. Well, our critical values are anytime we're 0 or undefined. So the endpoint doesn't really count if we're using the open interval because 4 is not included with that parenthesis, but we'd have critical values at x is equal to -2 and x is equal to 1. If you wanted to write down a reason, because f prime of x is equal to 0, which is how we defined our critical values, right? 0 or undefined. Cool. All right, and then it has what open intervals? Oh, that's new. We don't usually use open intervals. We've been using closed, but it's okay. We can do that. Is this thing decreasing? Now, this makes me want to write down this as an answer. -2 up until that 1 or from 1 to 4. But like, why would I not include the 1 there if it was decreasing and then it keeps decreasing? That makes sense to me that we'd still be decreasing, right? I don't know. So -2 to 4, completely okay to write in this particular situation. But if you overthought it because it says open intervals, I would be completely okay with that way to overthink it on this particular problem. There you go. That's it. Open intervals just telling me I don't want to include those endpoints, which then it becomes that question of whether or not we include the 1 where it was 0, but we were decreasing up until 1 and decreasing right after 1. So how do we really differentiate that? So either of these I would accept on something like example 8.